So let's have a look at ionic compounds. Dot and cross diagrams can show electrons being transferred and ions being formed. Dots represent the electrons from one atom, and the crosses represent electrons from the other atom. Square brackets and a charge, for example 2 plus, represent ions. So if there's anything with a plus or a minus on there, that shows you've got an ion. So for example, if we've got sodium and fluorine, we've got sodium atoms and they convert to ions in an ionic bond. The sodium atom transfers its outer electron to the fluorine atom, and that creates an Na plus and an F minus ion. So two ions are formed, Na plus, F minus. And both of these ions have a full outer shell of electron then. And same with calcium and oxygen. So calcium atoms transfer two of its outer electrons to the oxygen atom, creating again two ions, Ca plus and O2 minus. Sorry, Ca2 plus and O2 minus. And so both ions then both have a full outer shell of electrons. So just to recap a little bit of that, sodium is in group 1 and oxygen is in group 6. In a dot and cross diagram for sodium oxide, how many sodium ions would there be? So oxygen is in group 6, therefore it needs 2 electrons to fit its outer shell. Sodium is in group 1, and therefore it can donate, or it can give 1 electron from its outer shell. So we're going to need 2 sodiums to donate those 2 electrons that the oxygen needs. So we're going to need 2 sodiums in sodium oxide. So the calcium atom transfers its outer electrons to the oxygen atom and creates Ca2 plus ions and O2 minus ions, which both have full outer shells of electrons. And ionic compounds form when millions of metal atoms transfer their outer electron to millions of non-metal atoms at the same time. And what that results in is oppositely charged ions that are held together in what we call an ionic lattice. Now, an ionic lattice is what we call a giant structure, and they're held together by strong electrostatic forces between the oppositely charged ions. You might be thinking, what are electrostatic forces? Well, what they are is they are basically what we call ionic bonds when they are extended in all directions within a lattice. So what do we call the electrostatic forces that hold ionic lattices together? So remember, that is the electrostatic forces are ionic bonds. They're the things that hold a lattice together. Now you can work out the proportion of each ion in a compound using something called the empirical formula. And the empirical formula of an ionic compound is the simplest ratio of ions possible. So for example, if we've got the Ca2 plus ion and some F minus ions, in order for the charges to balance out, for the overall formula to be neutral, there must be 2 F minus ions for every single one of the Ca2 plus ions. Because if we've got 2 F minus ions, that is the same as 1 Ca2 plus, because 2 plus and 2 minuses equal each other out. So what we could say is the empirical formula is CaF2. So that's 1 calcium, 2 fluorines. Another example, so if you want to neutralize the charges, say we've got sodium ions and sulfate ions. So what you can do is sulfate is a 2 minus charge, has a 2 minus charge on it. Sodium ions have a plus charge on them, so you're going to need 2 sodium ions for every sulfate ion. So Na2, that's your 2 sodiums, and SO4, that's your sulfate ion. So in order for charges to balance out, the overall formula has to be neutral. There must be, for example, just remember this again with the sodium sulfate example, there must be 2 sodiums and 1 sulfate. That's because each sodium's got a plus charge on it, and the sulfate's got 2 minuses. So to balance those out, neutralize them, we need to have 2 sodiums and 1 sulfate. So again, we can say that the empirical formula is Na2SO4. If an ionic compound contained magnesium 2+ ions and oxygen 2- ions, what do you think the empirical formula would be? Well, remember, we've got to balance out those charges. If we've got a 2+ and a 2-, we can just have one of each, and that will balance each other out. So it's just MgO. What can we show using dot and cross diagrams? So the first thing we can show is the transfer of electrons, and we can also show the ions that are formed. And ionic lattices are giant structures formed by ionic compounds. Now remember, in order for charges to balance, they must overall be neutral. So take the calcium fluoride example again. So calcium is 2+, fluoride ions are minus, so you need 2 fluoride ions for every calcium to balance it out. So we can say the empirical formula is CaF2. What type of structure are ionic lattices? Remember, they're giant structures. The empirical formula of an ionic compound is the simplest ratio of ions possible.